Here is a very important topic: collections. A collection is a set of objects of the same type, similar to an array, but much more convenient. Soon I will show you why. Before analyzing the collections which are already present in Java, we'll create our own, and thus you will understand how they work. The program will be rather hard and at times it may seem complicated, so I recommend that you practice more after watching. It would be more effective if you delete all the code we'll have written together and then reproduce it on your own. So let's get to the code. Create a new project. Call it collections. Let's create a new package where we'll be working. Let it be called main. We'll only have two classes in it, both in this package. Let's create both classes. The first one will be called main, and it will be used to run our program. Create an entry point. So let's get started. Let's create a string array with the names of your colleagues. Call it employees. We'll initialize it immediately, adding several employees. For now, it's enough. Let's print it out in the console using for each loop. Because it's a name array, we will call the variable name and print it out. Let's run the program. Everything works. The array is displayed fine. The time goes by. We have a new colleague, Ivan. What will he do? The size of the array cannot be changed. Once the array is created, we cannot add elements to it. If we need to add one more element, we can create a new array where we'll copy all the data from the first array and add this new element too. Let's give it a try. Create a new array. Call it second. Assign symbol, new string. Its size will be the quantity of the elements of the first array plus 1. Now let's iterate the elements of the array and assign values to the second array. Second of I, assign symbol, employees of I. Thus, we are copying all the values of the first array into the second array. Its last element will be left uninitialized. Let's just assign a new value, second of second.length minus 1. It means we're taking the last element and assigning it the value Ivan. Now to the first variable employees. We are assigning the value of the new array. Type employees, assign symbol, second. The output of the array will be the same. Run the program. Everything works. Ivan has been added to the array. Of course, you might say that we can simply add a new name here and call it Ivan, and everything will work just fine. But this can be done only if we are granted access to the code. But what if the array with the employees has been created and you needed to add a new element to this array by clicking a button? You cannot add or remove elements of the array while the program is running. So you have to invent such kind of methods. And at the moment, everything works well. Now Igor has decided to resign. What should we do? How can Igor be removed from this array? Take the element which contains Igor. Employees of his index is 1, assign value null. that is empty value. Let's do this before printing out the list of all employees. Run the program. Now instead of Igor, null is displayed, and the array is still 6 elements in size. It means that we once again have to create a new array, this time containing 5 elements. Iterate the array and add all elements that are not null. Let's go for it. Create a new array. Call it new names. Assign symbol new string, and the quantity of the element will be employees.length minus 1. Let's iterate all the elements of the array. And if a given element, if employees of I is not null, add this element to new names. Type new names. At this point, access to indices of the second array is required. So let's add it. Let it be called J. We'll increment J, which means we'll assign the value of employees of I to variable new names of I. Once it's done, assign the value of the new array new names to variable employees. Run the program, and here is an error, because array employees contains one element more than array new names, and we are increasing the value of J every time. Delete this, and we'll increase only if a new element is added to the array. Type J++. Run the program once again, and now everything works. Igor has resigned. Now imagine this is a huge factory where thousands of people are employed, and on an everyday basis, dozens of them leave and hundreds get hired. How easy will it be to maintain this program? Collections are meant just for that. Let's create our own collection of strings, which will be easy to work with. What will it be like? Upon the creation of the collection, an array of 10 elements and variable size for storing the actual quantity of the element in this array will be created. We'll also create method add for adding new elements to the array, and then a new string is added. The value of the new string will be assigned to an element of the array with index size, and size will be increased by 1. This will happen every time a new element is added. If the array is full, that is size equals 10, a new array is created, and it's twice as big as this one. And all the values will be copied from the old array to the new one. We'll also create method remove, which will accept as a parameter the index of the element to be removed. This method will not return anything. What else will it do? Let's say we want to remove the element with index 5. In this case, our method will assign to this element the value of the element with index 6. Then it will assign to the element with index 6 the value of the element with index 7, and so on up to the end. Once it's done, we'll decrease the value of size by 1. It makes no sense to assign value null to the last element, because when a new element is added, it will be assigned a new value. And when we want to print out all the elements of the array, we'll do that up to the element with index size. Also, we must know the quantity of the elements in our collection, because variable size is private. We need a getter for it. To print out all the elements of the collection, we need method get, which will accept the index of an element as a parameter and return the element of the array by that index. That's all with the theory. Now let's get to the code. Let's create a new class in package main. Call it myArrayList. Create a private string array of 10 elements. Write private string, call it array, assign symbol, new string 10, it will be the initial array size. Create variable size for storing the quantity of the elements. Private int size. Initially, it will be equal to 0. Now let's create public method add, which will accept a string parameter. Within it, we'll take the string and add it to our array with index size. Write public, it will not return anything, therefore write void. Call it add. The parameters of string type, call it s. Within it, take our array, its element with index size, and assign the value of our string to it. It means that in this case, our array still does not contain any element, so size is equal to 0. When we add a new element, we take this array with index 0 and put the value of our string into it. Now the array contains one element, therefore, we'll increase size by 1. Now we must check if our variable size has become equal to the array length. If it has, we must multiply the array length by 2. For example, size is 10, and when we call method add, it will try to assign a new value to the array with index 10. But this array does not have index 10, so we'll encounter an error. That's why we need this to be checked. Write if size equals the array length, create a new array called new array. The quantity of the elements in it must equal the length of the first array times 2. Now we must copy all the elements of the first array into the second one. Write this. We are assigning the value of the first array by index I to the new array by index I. Now the second array is ready. It can contain twice as many elements, and it already contains all the elements of the first array. Now let's assign the value of the new array to our variable array. I hope this all is clear. When we approach the end of the array and there is no space for adding new elements, we create a new array which is twice bigger than the old one, and we add the elements from the first array, and we assign the values of our new array to variable array. Now let's create method remove, which will remove the elements from an array by its index. It won't return anything and it will be public. As a parameter, it will accept the index of an element. Let's recall that this method is supposed to do. If we want to remove an element with index 5, it will take the array element with index 5 and assign it the value of the element with index 6. Then it will take the element with index 6 and assign it the value of the element with index 7 and so on. It means we must take all the elements for int I, starting with the index we have passed, and iterate the array up to the second to last element. So we'll write I is less than size minus 1 and increase the value by I. In this loop, we must take the array element with index I and assign it the value of the element of the same array with index I plus 1. Once we've done it, we must decrease the value of size by 1. Let's reconsider why these particular values are being used. We have passed index 6 and we want to remove it. It means we start from element 6. We assign the value of the 7th element to the 6th one. The 7th element takes on the value of the 8th element and so on. If the array contains, for example, 9 elements, that is size equals 9, the index of the last element will be 8. Therefore, the last action to perform is the following. we must take the 7th element, I must equal 7, assign its value of the 8th element, 7 plus 1. That's just what we're doing. We iterate all the elements starting with the past index up to the second to last element, and then we increase the value of I by 1. And as we have removed one of the elements, we decrease size by 1. Now to know the quantity of the elements in the array, let's add a getter for size. We'll rely on the faster way, Alt plus insert getter for our size. And here is the last method which we'll need. If we want to print out all the elements of the array on the console, we'll need to get an element by its index. Let's create a method. Since our array contains strings, we'll return a string. String, call it get, and as a parameter, it will accept an index element and return array of index, that is the element we need. It's all set. Let's open method main, delete all the code from here, create a new object myArrayList, call it employees2 because it will contain a list of employees. Now we can add new employees. Type employees.add and Nikita, Igor, and so on. Let's add several employees. And using a loop, we'll print out the list of these employees. Create a loop. For int I equals 0, we'll print out until I is less than the array size. That is, employees get size. As you can remember, we've created a method to retrieve the quantity of the elements in the array I++. Let's print out employees.get I. As you remember, this method returns a string by its index. We're printing out. Let's run the project. You can see that everything works fine. We can see everybody here. Now it's not a problem to add a new element. Let's add one more employee. Now let's run and check. Everything's perfect. Now let's use a loop to add 100 more employees. Write employees and call method add. Let them just be called employee 1, employee 2, and so forth. Employee plus 1. Not to have employee 0, let it be from 1 to 100, like that. Run the program. I made a mistake here. We can see all our employees. The first ones were added manually. Others were added in a loop. Let's now remove somebody from this list. Let's remove Vanya. He has index 2, so write employees.remove 2. Run and see that Vanya has disappeared from here. So adding and removing employees is not a problem. Let's add several more functions to our class. First, when we remove and retrieve an element from the array, we do not check if this element exists in this array as such. So if somebody passes as an index a number which is too big or negative, we'll encounter errors. Let's correct this and add a function to check if index is greater than 0 or equal to it when we remove an element. If index is less than size, we'll remove the element. Otherwise, nothing will be done. The same for retrieving an element. If index is greater than 0 or equals it. If index is less than size, the element will be returned. Method get returns a string, and it must return a string in either case. Let's return the message, the element is not found, if the condition does not apply. And there is one more thing. We have method remove, which removes a word by its index. But it's not always convenient, because we can't know the index of an element. So let's add an overloaded method remove, which will accept as a parameter a string. Let this method be public and return nothing, void remove. As a parameter, we'll pass the string which we want to remove. This method must find out the index of the element which we are looking for and then call method remove with this index. Let's create a variable for storing the index. Its initial value will be -1. Now use a loop to iterate all the array elements up to size. When we see that our string is equal, we'll call method equals. Remember that it's not a good idea to compare strings using the comparison character. It's better to call method equals. We'll compare with the element of array of I. If the strings are equal, it means that the element is found, so we assign our index the value of I. We don't need the loop to process, so we'll break it. Write break and check that our index is not equal -1. Then call method remove and pass our index to it as a parameter. Open method main. Let's delete the loop for adding dozens of employees and for removing employee number 2. Let's now print out the list. The whole list is displayed correctly. Nikita, Igor, and the last one is Alexei. Now let's remove Vanya once again. Remove and write Vanya. Run the code. The element is removed. Now let's remove Alexei. Alexei is removed as well. Let's remove some non-existent element. There are no errors. Congratulations! You have created your own collection, which is almost an exact copy of the already existing collection ArrayList. We'll study it in more detail in our next lesson. Try to play around with our today's topic. It will be best if you delete all the code and reproduce it by yourself. It's the best way to understand and to memorize this topic. See you in our next lesson.